Right, I'm going to start you off on the next topic, which is sequences and series. Okay, you've already done a lot in terms of sequences and series. I think when you first did it, obviously you relate it to straight lines, and we're actually going to go back as far as that with the first type of series. And it's actually very similar, and in many ways, I'm trying to work out the different ways in which it is actually different and the different ways you need this version. And yeah, it's pretty hard to see exactly why it requires a whole new title as such, but nonetheless, we're going to roll with it. But basically, it's an arithmetic series. It's not an arithmetic series. It's an arithmetic series. And an arithmetic series is one which each term differs from the previous term by a constant amount. And so you've seen them quite a lot already. So 1, 3, 5, 7, 9 consecutive terms differ by 2 each time, 29, 24, 19, so on. Consecutive terms differ by -5 each time. Right, if you were looking for a formula for these, if it wasn't, I mean, this is more a series rather than the table that you might have had in previous years. So if this was a first term, second term, third, fourth, fifth term, you'd have a formula that basically connects the term within the series with its number in the series. Okay, so for example, because these are going up in twos, it's like the 2 times table, but it's obviously 1 less than the 2 times table. So you'd get something like y equals 2x minus 1 or y equals 2n minus 1, something like that. In many ways, you can actually still use that formula, but there's certain situations whereby a new version, in other words, the one I'm about to show you, might be more beneficial to you. Okay, so we're going to use this idea of an A and a D. So the constant amount is the common difference that we're going to call D. The first term of the sequence is denoted by A, and so we can kind of develop a formula like this. So U1 equals A, in which case U2 is going to equal A plus D. So D being the difference between the terms, we'd get the second one by adding that difference onto the first term. And likewise with the third term, okay, we're going to take the first term and add on 2 of those, that different amount, so on and so forth, until such a point as we get to what we're looking for, un, which will basically be a plus n minus 1, so 1 less than the term in the series, times by d. Okay, and that's our formula. That's a formula that you'll see quite a lot for an arithmetic series. Okay. And as I say, you can use this one. I want you to try and use this one certainly with the work that we're doing. But if for whatever reason you forgot this in an exam and a test, there's not much difference to going back to the way you used to learn this. Okay, but there may be some situations whereby you need this version, depending on what's given in the question. I'm going to show you a few examples which basically show you different situations whereby you might end up needing this version as opposed to any version you've done before. Okay, so try and memorize that general term where A is the first term and D is the difference between the terms. Okay, so for something like this, because we actually have the sequence in the first place, we could go straight ahead and we could work this out in the way that we've done previously in terms of straight lines and such. But I'm going to follow this through in terms of what we've just looked at in a general term of an arithmetic series. So we're going to find the 100th term, okay, and we're going to do it. I'm going to do it by this way, am I? Yeah, well, let's see what happens here. Okay, so this is how we may have done it in previous years. I mean, I'm teaching this with my second years at the moment, to be fair. So the term number, the first term is 3, second term is 7, so on and so forth. Okay, and they're going up in 4s. So if you remember, we talked about a multiplier. It's basically like the 4 times table, but slightly different. Okay, if it was the 4 times table, it would be 4, 8, 12, 16. So we can see that hopefully this is 1 less than the 4 times table. Okay, so un would equal 4n minus 1. So that is the way that we've done it in years gone by, okay? But in terms of an arithmetic series, in terms of the general formula for this, what we want is the first term, which is 3, and we want the difference between the terms, which is 4, and we want to base our formula around those 2 numbers, okay? So the difference is 4, in which case a un will equal 3 plus n minus 1 times by 4. In other words, 3 plus 4n minus 4, in which case it's 4n minus 1. It actually ends up, it's exactly the same sequence formula. But this method is more useful for more types of examples, as you'll see going forward. Okay. To be honest, I've said that, I've actually written that, and I've gone through these slides. I've been written them last year. And you can use this method virtually every single time. Okay, so when I find one that you can't use this method, I'll let you know, but just nonetheless try and use this method just so we can get used to it. But nonetheless, the question is actually asking us for the 100th term, in which case it's 4 times 100 minus 1, which is 399. Okay, right, so different kind of question. So this is not the kind of questions that you've got previously, but nonetheless, you can actually still kind of do this in the methods you've previously learned. So for a given arithmetic sequence, U10, okay, so the 10th term in the sequence is 38. The difference between the terms is 3, and n is 10, obviously. And the first term of the sequence and the formula for the find the first term of the sequence and the formula for the nth term. So from the question, we know that U10 is 38, D is 3, and n is 10, in which case we can start building up our formula. Okay, so 38 equals the first term, which we don't know, plus the previous term, or the number of the previous term, which is 9, times by the difference, which is 3. Okay, 9 times 3 is 27, so obviously we add 11 to that to give us 38, in which case A must be 11. First term is 11. Okay, and this can build up our formula to allow us to find the nth term. Okay, so it's 11 plus n minus 1 times by 3, 11 plus 3n minus 3, and just simplify it down. 3n plus 8, 8 plus 3n, either way is fine. Okay, but if, as I say, if you go back to it and you thought about this, so the way you've done it previously, if you had the list of terms in the sequence, okay, the first thing you'd want to find is the difference between them anyway. And you'd know that it's basically based on the 3 times table, so it would be 3 times by n. Okay, for this one, if this is the 10th term, okay, then it would be 3 times by 10, and then to get up to 38, you add on 8. Okay, so you can still use that previous method, but we're just, trying to use this one nonetheless. All right, another question. Third term in an arithmetic sequence series is 14, and the 5th term is 38. Find a formula for un and write down the first 4 terms of the sequence. So U3, the 3rd term is 14, the 5th term is 38. Okay, because it's an arithmetic series, we know it's going up in a constant amount. Okay, so because if this is the U3 and this is the U5, you can probably hopefully see the difference between them is 24. Half of that difference is 12, so the 4th term must be 26. But anyway, un equals a plus n minus 1 times by d. So u3 will equal a plus 2d, and u5 will equal a plus 4d. Okay, a plus 2d equals 14 because we know the 3rd term is 14. And a plus 4d is 38 because we know that the 4th term is, or the 5th term, sorry, is 38. Okay, and then we can kind of combine these together simultaneously. We can get 2d equals 24. Oh, d is 12. Okay, which, you could learn from before anyway. But anyway, a plus 2 times by 12 is 14. A equals 14 minus 24, in which case a is minus 10. But again, I think you could have worked it out from before. If they're going up in 12s, then if this is the 3rd term, then this will be 3 times by 12. So 36 minus, what do we take away from 36 to give us 14? We take away 22. Okay, so you're going to see this in a second. There you go. But let's roll with it. Okay, first 4 terms in the sequence are 12, 20, and 28. Okay, first 3 terms of an arithmetic sequence are 3x, 20, and 7x. Ooh, this one's a bit different. Find the value of x and hence state the first 3 numerical values of the sequence. Okay, so what we're basically saying is the difference must be the difference between these two and then the difference between those two, and we can create 2 equations from that. Okay, so 20 minus 3x and 7x minus 20 are our 2 equations, and they have the same difference. Hence, we can get an equation from them, okay? And if we've got an equation that's just in terms of x, we can solve it. Okay, shift everything to one side, 10x is on one side, 40 on the other side, x must equal 4, in which case the first 3 terms of the arithmetic sequence are 12, 20, and 28. Pretty straightforward, I hope, okay?